Welcome on the Superpowers of Kotlin Delegation, where we will be learning about gentle art of delegation. But because we are very nice people, we won't be delegated to other people. We will be delegated to objects. And so in this presentation, we'll learn about few important features about delegation, about interface delegation, and about property delegation in Kotlin and in general. But let's start from who am I? Why am I here talking in front of you? So my name is Marcin Moskała. I am an author of a book, Android Development with Kotlin, and I'm finishing a new one, Effective Kotlin. I started a school that is, as far as I know, one of the biggest Kotlin teaching school in the world, that is KT Academy. We are teaching worldwide, and we are based in Poland, so we also do some open workshops in Warsaw, and our first one will be in 2 weeks in Krakow. So we also open for Krakow with open workshops. And so I am going around the world teaching, writing, and doing programming and working with different companies. But delegation for me is very much different than other Kotlin features, because I have my personal story with delegation. When I started the first book I mentioned, Android Development with Kotlin, before we were no one then from the publisher's point of view. And so before we even started contact with any publisher, we decided that we need to write something, to show something. And so we had to choose, I chose the list coupled chapter. And this was delegation. Delegation is very barely coupled with other Kotlin features, so it's very easy to write about it. But when I was writing, I was digging very deeply into delegation, and I started feeling some connection with it. I started seeing things. This is relatively new thing in programming world, and so there are many things that are still undiscovered. And then when I started digging really deeply, I got so much creative that I just had to bug this idea out of me. So I started writing some code to test ideas, some small libraries. So I was, suggesting different. I was writing articles suggesting different approaches. So this time was when I was, out of the life. I was just working, writing book, writing libraries, and it was one of the happiest moments in my life. It took like few months basically, but it was really happy moment. I felt so creative and so innovative that it's like I would go back there and could spend this time again and again and again. Of course, it's impossible because, of course, 18 hours in front of computer is not good for your car. And so, after that, I have a very personal story with delegation, and I feel very personal connection with that. And today, I would like to share some of my passion with you, even though nearly over 2 years went after this time. In this presentation, we will talk about two main kinds of delegation. One of them is more pure brother. It's very strongly connected to what delegation really is. But it's not the cool kid. It's rather the one that everybody ignores in the class. The cool brother will be a little bit later. It will be the property delegation. But it is the direct a direct result of what we will talk in the first part. So let's start from interface delegation. But first, a stupid question. What is delegation? Who can tell me what is delegation in the shortest word? What is delegation? Yes, this is a general. in programming, this is a very good answer. This is the general idea of delegation. And particularly in programming, Yeah, this is a very good description, but in even shorter, it's kind of a pattern. It's one of the pattern in programming world. And this pattern particularly looks like that. So in this case, we have some object, which are player, which composes another object, player. But it implements the same interface as this other object, and it implements a method that he passes to this other object. So in this case, we say that this player is a delegate. Because we hold it, we extend the same interface, and we delegate to it. And in the whole idea, we say that whicher player class delegates methods defined in a player interface into RPG game player. Do not confuse delegation with composition. If we wouldn't have the same interface, we would speak about composition. We would compose player object and use it. But when we add the same interfaces, then we have something extra. This is like an extent over composition. We have polymorphic behavior, and we are talking about delegation. Clearly, delegation is an alternative to inheritance. The same could be achieved using very simple inheritance. Of course, in this case, RPG game player would have to be open. It's a small typo, but you can see the idea. But there are very strong reasons that are well described by authorities and by influential books why we should rather avoid, in many cases, we should avoid inheritance. And they are described in influential books like Effective Java and Design Patterns. And let's take a look at a very simple example. So let's imagine that you need a hash set that additionally counts how many elements were added. Simple. You just make new object, you inherit from hash set, you override methods, add and add all, and you bump your counter every time you add some methods. Does it look good? Does it look good? Do you think it looks good? No? I see some faces. You probably are familiar with the book Effective Java. So the idea is that when we call add all, elements are added twice. So the reason, you would clearly tell me as you are familiar with Effective Java, the reason is that when we call add all super, this add all calls add, so methods are calculated twice. Okay, very simple. We can just remove this other add all. But it does not solve the problem. What if creators of this solution of hash set would one day need to improve it and make better add all that adds elements in more efficient way and does not need add method? So then our class would be broken. The big point is that the fact that add all calls add, it's not external behavior of this object. It's an internal behavior. It's something that should not be visible from outside. So, and it's not documented. So we say that inheritance, to some degree, breaks encapsulation. And this is one problem with inheritance. And this is the first reason when we generally avoid inheritance, we prefer composition. So when class is private final, clearly we cannot use inheritance. Then when it's not designed for inheritance, it was the previous case. There are also other important reasons. When there is no is-a relationship, this is formally known as Barbara-Liskov substitution principle. So if subclass should only extend superclass, it should not modify it. If it modifies it, it's like asking for trouble. It's a material for another presentation. It's well described there, but it's basically a very bad idea. And the third reason is that when we need only some functionalities, so when we inherit, we take everything, what sometimes we don't need, what breaks interface segregation principle. Basically, we prefer to specify what do we want, and we can specify it. In composition, we take what do we want. In delegation, we specify it by an interface. So yeah, use composition. This is the general solution. But composition do not have polymorphic behavior, and if we need polymorphic behavior, then we can use delegation. But as we started as in our first code example, delegation is hard. That's why Kotlin introduced a feature that makes it easier. And our first coding example could be simplified into the following code. So what you can see in here is that we still implement interface player, and we still have a delegate, but we do not need to explicitly specify property that holds this delegate. Instead, we just say how this object is created, what is the object, and we will automatically delegate to it all the methods from interface player. This can be used pretty widely. We can delegate to any object that is accessible at this point. We can create object using primary constructor parameters. We can delegate to something from primary constructor parameters. We can even delegate to any object that is accessible at this point. Does it make sense? Where this feature is particularly useful, in another common pattern, I think you will be more familiar with it. This is a decorator pattern, and the most typical Java example is how we compose streams. So in Java, if you need to read a file, you start from file input stream, but then you need to some buffering functionality, so you wrap it into buffered input stream. You need to unzip it, you wrap it into zip input stream. You need to read an object from it, you wrap it into object input stream. So this is very clear decorator pattern. Decoration is very popular in programming, even if you don't know about it. If you use streams in Kotlin, streams are decorators one over another, the same as far as I'm concerned in Scala, by the way. So this pattern can be significantly, I mean, what is annoying in this pattern is that input stream, and this is a class, so it does not apply, but basically most of such interfaces have many methods, and you need to implement them all. And you probably modify only a single one. And how it can be improved with delegation, it can be improved by delegating class to interface to an object, and then you only modify methods that you want to change. In this case, we modify play game, we add arg before we call play game, and so our Witcher player can be wrapped with this play hard and will have a modified behavior. In this case, it's not really a difference, as player had only single method. But if player would have, I don't know, hundreds of methods, we wouldn't need to care about any of them. We only change those that are changed. So this is the improvement. Does it make sense? Okay, but let's talk about the cool kiddo in the class. I think that this is what took you in here, property delegation. This is what allowed us to make easily lazy and observable property. But before we start with property delegation, we need to grasp the concept of property itself, because property is highly misunderstood by developers from other languages. People think that property is like a Java field, and to some degree it is, but the big difference is that property is encapsulated by default. That's why we don't need to use getter and setter. We just use it as if it were property, because it's obvious that it's encapsulated. Everything is encapsulated by default in Kotlin. So, why making it more messy? So, property in Kotlin under the hood has getters and setters, and we can take advantage from that. We can always define custom getter and custom setter. So here is a custom getter that uppercases the value when it's gotten. So you can set value from lowercase, and when you get it, it will be in uppercase. Does it make sense? Here is also a custom setter. This setter sets field only when it's not null or blank. By the way, value is a nullable property, and we can do that because is null or blank is an extension function on a nullable property. I've seen it was on a presentation yesterday. Kotlin is for hipsters. But what is even more important is that people confuse property and fields in Kotlin because they can behave similarly. But the big thing is that property do not need to behave like a field at all. It does not need to have a field at all. So here we have a property that is defined only by getter. And so it's compiled into get full name. There is no field under the hood at all, okay? This is very useful thing. Like, imagine that you have a date object. In some class, you have a date that is Java date, okay? And years come, and then for some reason, you cannot keep date anymore. You need to, I don't know, there is problem with serialization, or you lift it into something that is not Java specific, or whatever. But so you need to hold field somehow else. But you used it from many places, and updating it all would be huge pain. So what you do? You just modify your date so that date will not have field anymore, but will be defined by getter and setter. Getter that builds date based on milliseconds, and setter that sets milliseconds based on date. So this is a huge advantage of properties. Properties are not like fields. Properties are getter and setter. This is why we can make extension properties. This is why we can place properties in interfaces. And this is why we can have property delegation. So let's smoothly move into property delegation topic. Imagine that you have, this is an extreme, you have a repetitive pattern in your code. This is an extreme, it's very clear, but you have a lot of repetitive patterns around properties that couldn't be extracted. To name one most popular is the lazy. We all implemented lazy field, lazy property many times in our life. I implemented it as a Java developer many times. And so we have some repetitive pattern, and we want to extract it. And we cannot do that using classic features, but we can do that using property delegation, and this is how it looks like. So what we do is that we still have properties, but we delegate them into an object. Here is an object we created using constructor. And this object has methods, getValue and setValue. As you might have noticed, as I just told you, property is not a field. Property is a set of functions, getter or getter and setter. And so when we delegate property into an object, this object needs to have functions. So getter would be delegated to getValue, setter would be delegated to setValue. To understand what exactly is going on in here, take a look at this slide. So on the left side, you can see what is on the left side you can see what is your code. On the right side you can see what is this code compiled to. So you can see that on your getter this property does not have field. Instead there is some delegate object, and in your getter you use getValue, in your setter you use setValue. There is also this reference and property reference. They are there to help to give you more possibilities when you define what's going on in this getValue. You can reference to context, you can reference to property itself, but what is the most important part is that the other object take responsibilities of your getter and setter. So it's really easy pattern actually, isn't it? Makes sense? It's really easy under the hood. An alternative introduced a bit later is provide delegate. That does exactly the same, but object can pass responsibility of creating this delegate to another object. But on the end, it's exactly the same. And so this pattern can be used to easily replace all the common patterns around properties, like binding, injecting, or lazy. So lazy is in a standard library. Injection is implemented in many good libraries like coin, and binding is, wow, it's trivial. I will show it to you. And this is how it looks with property delegates. Okay, so to understand this idea deeper, let's talk about standard library property delegates. Okay? And first of all, we will learn some new tools, but second of all, we'll grasp the idea and see some possibilities. So let's start from the simplest one. There is a problem in Kotlin. Imagine that you, in any language, imagine that you have a property that you need to set a bit later. For instance, you have some init function in tests or onCreate function in Android, and you need to set something there. Making it nullable, and then unpacking it into non-nullable is not a good solution, because it will be set before the first use. So what we use instead is a late init, which is a good solution, which is a proper solution to this problem. But there is one limitation in Kotlin. Late inits still cannot be used for primitives, and so in here we use integer, so late init is not possible. Instead, we could implement this pattern with backing property, but first of all, it would be really ugly, and second of all, it would be a repetitive pattern. So instead, we have a property delegate that is called not now, and it's present in the delegates object in standard library. How not null delegate looks like, and I showed it to you only for you to understand better property delegation. This is practically the whole implementation. This is the object that we delegate to. It has some value that is nullable, but we force, by using generic type parameter, for t to be not null. So it means that this value will be null only if it haven't been set yet. Okay? So in the setter, we just set it. If we set it, means it's not null because of generic restriction. When we get it, or if it's null, this is an LVS operator, we throw an exception. Very, very easy. This is the simplest reasonable property delegate practically. Does it make sense? Are you ready to go next? Okay. Another very repetitive pattern is a lazy delegate. So lazy delegate is when we do not want to create object during class creation, or when we cannot create object during class creation, but instead when we want to create it during the first usage on demand. When you need it for the first time, then we'll create it. So classically, this is what would we need to implement it. It's not really proper implementation because it's not fully thread safe, but it's like how it would be probably implemented in most cases to have some degree of thread safety and proper lazy initialization. This can be replaced in Kotlin with this single line. So we just say that user repo property is delegated to lazy, and inside the lambda we specify how value should be created. The funny thing is that you could implement it yourself. If lazy wouldn't be in standard library, you could implement it yourself. It's like 20 lines, maybe less, with proper synchronization. So lazy is not a built-in concept. It's just one of the concepts that are result of property delegation. How we can use it? There is a very simple example. There are many examples, but I particularly like this one. as it was a huge discovery for me, like, whoa, over 3 years ago, probably closer to 4 years ago. So in Android, we have had this case that we had to bind our properties to parts of our view to be able to modify this view, but we couldn't do that earlier than in onCreate method. And so, since we wanted to use it all around the class, we were setting properties on top, and then we were setting all those values we are using findViewById in onCreate. So there were many libraries like Butterknife that were helping us with that using annotation processing. But in Kotlin, Butterknife would be useless, as first of all, we could use lazy delegate to find this view by ID, what on the end would lead to exactly the same result. If you try to get it before onCreate, you have an error because it cannot be initialized before onCreate, but we will surely use it after onCreate, so we have everything in single place, our name is used once, everything is shorter, and you have a highlight when something is unused. But a very simple function, extracted, bind view, it's an extension function, and everything is looking much better. So this is Butterknife, nearly whole. I mean, there are a few other features, but this is main functionality of Butterknife in a single line. The same can be applied and is applied to many other things. We bind arguments. For instance, in here, we specify that there is some extract to the argument that we need to read from extras, and we cannot read it during class creation, but we can make it lazy, and so we will use it clearly after class is created. Does it make sense? Lazy delegate, I don't know if I have I don't have an empty slide for that. Lazy delegate is pretty popular for many reasons. When you cannot create something during class creation, when you want to make your class lighter, this is a popular case. When you have a class that depends on strong heavy dependencies, creating the heaviness of the class is the heaviness of each of those dependencies. Instead, you can make them lazy, so the heaviness of their creation will be spreaded to use. There are many cases when we like lazy. Another popular property delegate is observable. It's also in the delegates object expression, in object declaration. And so observable acts like a normal property, but additionally calls lambda expression whenever value changed. So in here, we change name to Marcin, to Igor, and then next to Igor. And whenever we change name, also lambda expression is called, so it is shown how property changes. Also pretty useful thing, a few Android examples. First of them is when you need to notify some object when this property is changed. So in Android we have an adapters that are like a list holders, and in these adapters we hold this list, and whenever it changes we need to redraw whole list. So we need to notify dataset changed. Another very simple binding, we can bind the fact that drawer is open to opening and closing it. So when someone sets drawer open to true, then we will open that. When someone sets drawer open to false, then we will close that. So it's a very simple property binding. And the last case is a bit funnier. So I had a very complex view to implement in my job where there were many fields that they were dynamic and they were interacting with each other. So once you change something on one view, other views could vanish or could change values, and so it was pretty complicated. And so I decided that I need, one general presenter for the view and sub-presenter for each part. But this presenter had life cycles, so they need on create and on destroy. And so what I did is that this main presenter kept presenter's property, and this presenter's property were observable. So whenever this list was changed, we checked, and the one that were before old minus the one that are now, those are these ones that are not there anymore, that were removed, so we need to destroy them. We call on destroy. The one that were are new but were not before are new one, and we need to create them. This is just a simple example. There are many things that can be used with observable. A brother of observable is variable. It additionally decides if value can change or not, so it returns either true or false. True means, yeah, let's change it, let's do that. False means like, nope. And so when we in here require to have our list with at least 3 elements, when we on the usage on the third line we try to set list with 1 element, nothing happens, and list and property is not changed. So like observable plus it can decide if new value should be set or not. A typical example is when we have some property with some requirements, and so at the beginning we check if new value is valid. If it is, then we can show it, we can do something with that, and we allow it. If it is not, then we can show some error or some warning or whatever, and then we show, and we do not allow modification. Does it make sense? Good. Another example is map. I will engage you in a moment. Another example is map. So map can be used as a delegate as well. Map can be used as a delegate as well. So when it must be a map with string as a key. And so when we ask for a value, the value will be, we will search in the map, and if there is a key with name of this property, then it returns the value of this based on this key. So in here we have a map with name to Marcin, and so when we delegate to this map, and then we use ask user.name, then Marcin will be returned. Does it make sense? One big question is, how is it possible? I told you that you need get value or set value to be able to make delegate. Does it mean that map, which is an interface, has get value implemented inside? Any ideas? I heard something, but default methods. This is even easier. I mean, it could be done, but you would still, if you would add these kind of small things inside, you would have a lot of things, and you don't want that. You want small and fit interface. Any other ideas? How it was solved? No reflection. We don't like hacking in Kotlin. There is actually the delegate. It is delegate because we have this get value defined as an extension function. So this is an extension function on map, and it's particularly an extension function on map with string. It's possible because extension functions, this is another discussion, another presentation, but extension functions are under the hood normal functions, and the receiver is the first argument. So extension functions are extension not on class, but on a type. And so we can make an extension function on interface with concrete key type. And so when we can use it as a delegate because there is an extension function get value defined for that. And this extension function is used to get value and give it to us. So another engagement for you. Let's think about a small puzzler. So what are puzzlers? So in my workshops, I always give a lot of puzzlers because they force people to think and to challenge themselves. So puzzlers are kind of a tricky snippets of code when I show you some code like this one, and I want you to tell me what is the result. So here you have some options. It might be 0, 0, 0, those numbers, null pointer exception, or not some such element exception. Just to describe what is going on in here, we create population with population and with some map. Then after some time, we set population cities to empty map, and then we print ln values. So it will be kind of a guessing, but let's think about it and let's guess what will be there. By the way, I was asked quite a few times. I mean, not me particularly, but I was engaged in the discussion on Kotlin Slack to explain this behavior. That's why it's here. We can cut it on the video. Okay, so I want your hands up. So first of all, who has a hand? Who has a hand? Put your hand up. Do you have a hand? Oh, quite a few people. Okay, so who thinks A is a good answer? Oh, one hand. Who thinks B is a good answer? Oh, a bit more. Ah, close to half. And C? One. And D? Oh, also quite a lot. So, and it's B. So about half of you is right. Probably you know this puzzler because it's not easy, but you're right. And to understand this behavior, let's first think about normal properties. So when you have property A and you set value to that, and then you have property B that is equal to A, they have equal value. But then when you change property A, property B won't change. It's like programming 101, yeah? But for some reason, people believe that delegates will behave differently, but they don't. So when you have a property map and property Mars that delegate to property Mars, they are pointing to the same value. But when you change map, Mars will not change. Does it make sense? So it should be an expected behavior. And to understand it even deeper, we can go back into our most important slide, that is this one, that clearly shows that we do not reference to the property, but to the delegate, but we save it in another property. So it's pretty clear that once, if we would say user by user something, and then change this user something, it's pretty clear that the value of user will not change. Does it make sense? Okay, so if you want to change internals, what you do is you use a mutable map. I see that there is lack of enter in here. When you use it's actually duplicated. When you use a mutable map, then you can modify it. If using a mutable map, you would say you would do map.clear, then you would properly clear all the values. It's pretty, I think it should be intuitive that map that is immutable should not, when we delegate to that, it should stay always the same. So the big question is, okay, so what do we have from this property delegation? What possibilities that it gives us? Because I've shown you some things from standard library, but the big point is that you can go home and start replacing your patterns around properties or your annotation processing library based on properties with property delegation. So how it can look like, I would like to show you a few examples from that were my ideas, and I distributed them in somehow, but of course you can copy them. So what was annoying to me, right now I moved more into MVVM, but I used to do MVP development to be able to do unit testing. And so what I was doing is that I was hiding activities or fragments behind some interfaces, and this is what was served to presenter that presenter can do. But what was annoying is that are all those small methods. It was solved by MVVM, but back then it wasn't solved by nothing. So we were setting email using set email method and getting email using get email method, which translated into these small and annoying methods that were very, very repetitive in many, many fragments or activities. And so how I improved it, instead of using this get email and set email, I replaced them with properties. Properties can be in interfaces because they are getters or getters and setters. So it's nothing else but interface with get progress view and set progress view, etc., etc. And in my actual code, I use bind to visibility. Those are small methods that I implemented, and I distributed them later in a library called small library called Kotlin Android View Binding. So this way, I replaced a repetitive pattern of setting and getting something. Another thing is preference binding. There are tons of approaches to deal with preference binding, so I had to make my own, clearly. The classic Android way is really annoying. Whenever you want to modify, you need to get these preferences, edit it, modify it, then commit that. When you get it, you need to get this object, get something. It is really messy way. You need to store these keys somewhere. You need to create this preference object, and so it's really annoying way. So what I did instead first was a funny connection of extension property and property delegation. So I made a library that makes it possible to delegate extension property on shared preferences to some object that will be storing this automatically on preferences. So in here I can just say preferences dot something equals to something. So I have type safety. I don't need to store keys separately, and it's generally easier. But what was problematic in this approach is that it didn't allow testing, and you still needed this reference to these shared preferences, what was annoying because it requires context, so it couldn't be used in properties. So instead what I did later in another small library preference holder, you have links down there or under every slide, and slides will be on my Twitter published today at Marcin Moskała. So I did an object. I made it possible to make an object that represents our preferences, and in this object we just make property and we bind it into delegate that described what is the name of the key, some initial value, and that's pretty it. So then you can just say pref dot canitPy equals to something, get this value. So again, you have type safety. You don't need to store keys. You have suggestions what you can do. So it's easier. Also, I introduced testing. Oh, there is no slide for that, but I introduced testing mode for that. So I finally could set up testing mode that allowed me to properly use it in unit tests. Another example is like binding extras. So there was a small library, it's actually not a small one, but a library I used to maintain. It was activity starter that generated starters for activity with arguments. So this activity has 4 arguments: name, ID, grade, and passing. First 2 are optional. So based on this specification, you have a bunch of starters that are possible to start this, can be used to start this activity. What I also implemented property delegation to lazily inject this value. This approach is also used to dependency injection. Here is a codane used to inject something. There is used to inject values. Pretty similar is coin. I use it currently. And they base on the same idea. And there are many more libraries based on that for databases, for injection, for common pattern around properties. So you can see that there are many possibilities. What I showed you is just the tip of an iceberg, but there are many possibilities what you can use property delegation for. But the big question that I would like you to ask to yourself at the end, but what exactly did it change? As you have seen, this is a pretty simple feature. It's not something complicated. It's a very simple feature that just compiles into something a bit more complicated during compilation time. So what did it introduce? And to see it, I would like you to think about the alternatives. So first idea is a function. But function is not an option at all. I mean, function do not hold state. So if we need to hold state, and we basically need to hold state, otherwise we wouldn't need any property, then we need to define this state outside of a function, and so we ended up with specifying getters and setters that are repetitive again and again, so no improvement. What is an alternative to property delegation and could be used before is a class. So instead of by lazy, we could make some lazy property class. And on the end, delegate is an instance of a class. But it's an instance that is hidden behind an interface. The simplest and the most intuitive interface we know. It is property interface. We know how to use property. We know how to set something on property and how to get something from property. Class can be complicated, and they often are. You don't know what is there. You don't know what is in this lazy property. New developer can introduce new methods and make it complicated. Classes needs to be understood. We need to update our knowledge about classes, and it's easy to make them complicated. Properties are just properties. This is the simplest interface we really well know how to use. And also, if we would use class, we would need additional level of complexity. So, like something like get value first to get this value. So this is the difference. The difference is that we could use classes, but we wouldn't use classes because it would introduce additional complexity we don't want in our project. So the same in here, instead of bind to text property, it was possible even in Java to make some bind to text class, but it would be additional level of complexity. It would be significantly slower, and it would be, I would say, dangerous. And also we would need to unpack it first. So even though it was possible in Java, I don't know anyone doing that in real. We preferred annotation processing libraries, which were very complicated anyway. Okay, and that's everything from me. As far as I know, I have this program with questions, so I will answer to them. But about the presentation, this is everything from my side. So I'm not holding you in here. We are finishing our time. So thank you for your attention for now. And for those who are interested, I will spend a minute and answer to your questions. They need for an interface for delegation requires the target to have public methods. Is there any way to keep the target methods or class internal? Yes, it is. And it is a very common solution. So let's say that I make this not null. Okay, I will make it bigger for you. So when I have this not null, this is a method. this is a method in an object declaration, delegates. Yeah? This is a method that returns an interface. Read-write property is an interface. It has two methods, getValue and setValue. This is all we need. We don't need to implement this interface, but this interface is helpful because it helps us keep the signature of getValue and setValue. It's also helpful because we can use it to hide actual implementation. So actual implementation is not null var, which is not exposed at all. Actually, it's private. So I believe this is exactly the answer to this question, if I understood it correctly, because this object is kept private. Could be internal, but it's actually private. And it's possible because it's hidden behind an interface. Make sense? It's easy to find it. Not null delegate from delegates. Hidden behind an interface, there is a private class. Okay, moving into next question. Is it possible to use generics in property delegate? Yes, I mean they are nearly always used. Like in here, they are used as well. So we have a generic type parameter with a restriction, upper bound restriction that it needs to implement any. If you are not familiar with typing system, if you are not familiar with Kotlin typing system, the point is that any is a super type of every not nullable type. So this is a restriction, meaning that we don't want it to be nullable. So, and then we just make this interface is just generic, and this class is also generic. So yes, most property delegates are generic. That's why they are useful. Can we delegate to more than one? No. I have this strange question every time, and I thought about it many times. How would we want to delegate to more than one? Would we want to compose them, or call? I think there is some idea of composition in here. If you would really want to compose them, you can make delegate decorator using two things that we learned today. So if you truly want to something like that, you can make class, I don't know, delegate decorator with delegate. We will reuse this interface for the sake of simplicity. And we need it to be generic. And then we can make our decorator. Okay, so by delegate, we need it to be a property. And so we have a decorator. Now we can decorate our not null with this decorator. Yeah, does it make sense? And if you want to add some additional behavior, then you can always add it. So it will, I don't know, make every time we get value, you can print trololo, and I don't know, then call this delegate get value and return it. So if you want to compose, I mean, yeah, if you want to compose objects, you can use decorator pattern. What I believe is a answer to this question. I hope it is. So if I'm correct, because I'm doing it for the first time, just like you do, I believe, I guess. So I set some, value, and then if I am correct, whenever I get value, I should have printed trololo. Yep, looks like it works. Let's add something to see if delegate works itself. Maybe print ln. And here I will add ln as well. Yeah, live coding, as you can see, I have it in my fingers. Live coding is a common part of my workshops as well. So yeah, so I think this makes sense. This is how, if you really want composition of delegates, you can use the decorator pattern like with any object. Or there are other patterns you can use. So this is the third question. This is, lazy object creation, not class creation, the repository example. Yeah, yes. I mean, yeah, this is a confusion in general in wording. It's lazy object creation, class initialization that creates an object. Yeah. Wording. As far as I know, Kotlin, I don't know any other languages with property delegation. I think there is something that is different, but something to some degree similar in Groovy. I don't know any other languages. Is there anyone who knows any other languages with something similar? No? So probably there is no. Okay, so this was the last question. If you have more questions, ask me. I will stay in here for some time, and I am around in the conference. So thank you for your attention. I hope you liked it.